Hello everyone. In the previous video, we discussed about the application and examples related to the scatter chart. In this video of the series, we shall be discussing about the control charts. The control chart, also known as the Shewhart chart, is a graph used to study the process variation or change in the process over a period of time. It was developed by Dr. Walter A. Shewhart. He used to work in the Graham Bell's lab where he developed the statistical process control, and control charts are the outcome of his work. The intent of the control chart is to monitor and control the process by studying the variation. A control chart always has a central line for the average, the upper line for the upper control limit, and a lower line for the lower control limit. There are various types of control charts based on the type of data. Now, you can pause this video for a while and can study this flow chart. This would help you in understanding with respect to the selection of an appropriate control chart. Let us try to understand the most commonly used control chart, that is average range chart, also called as X bar and R chart. So, as you can see on your screen, we have collected the data for a subgroup size of 5 and for a subgroup frequency of 25. Now we are going to create an X bar R chart for this selected data. For that, we'll start with computing the average for each subgroup frequency and the range for each subgroup frequency. To start with the average, I'll use a direct formula is equal to average, and I'll select the first subgroup frequency and click on enter, and here is the average. Similarly, I'm going to calculate the range for the first subgroup frequency. So it will be is equal to the maximum of the entire data set, because range is calculated as the maximum minus minimum. So at first I'm just calculating the maximum and I'll subtract the minimum. I'm using the direct function to calculate the minimum. And here we are with the range for the first subgroup frequency. So what can I do now is I'll just drag it. So after dragging it, I'm able to calculate the average and range for the entire subgroup frequency. Once I'm done with it, the next step is to calculate the overall average for the X bar and for the range. This overall average is called as X double bar and R bar. So for X double bar, I'll use the same formula is equal to the average and select all the subgroup size frequency. Similarly, for the average range, I'll use the same formula and I'll use the entire. So here I am with the X double bar and the R bar. Now the next step is to calculate the control limits for the average chart and for the range chart. So for that, what I'm going to do is I'm going to bring that X double bar and R bar here so that it is easy for our computation and simultaneously for creating the chart. So I'm just bringing this data here is equal to X double bar, and similarly for R bar is equal to the R double bar. Now let us create the control limits. Now for control limits, we should remember one thing. Walter Shewhart, the creator of control charts, he mentioned that control limits should be 3 times the standard deviation from the center line, which means that control limit shall always be calculated as mean plus minus 3 sigma, where sigma is the standard deviation. But in order to reduce the probability of error happening in the process, which is actually detecting the assignable causes of the variation. So for that, we use a specific or a different formula for the X bar R charts. For X bar chart, we are going to use this formula of X double bar plus minus A2 R bar, and for R chart, we are going to use this formula, that is D4 R bar and D3 R bar. So let us just use it. So for the average chart, the upper control limit, it shall be is equal to A2 R bar plus X double bar. So here I am going to take the X double bar plus A2 R bar. So A2 I'm going to take it from the table of constants. For a subgroup size of 5, A2 is 0.577 multiplied by R bar and enter. Similarly, for the lower control limit, there is only going to be a difference of minus sign, that is x double bar minus A2 multiplied by R bar. And similarly, I am going to calculate for the control limits for the range chart, which is equal to D4 R bar. So D4 for a subgroup size of 5 is 2.114 multiplied by the R bar. And the lower control limit for range chart is equal to D3 R bar. So D3 is 0 for the range chart for a subgroup size of 5. So I have calculated the upper control limit and lower control limit for both the average chart and the range chart. So what I am going to do is, I am just going to copy these values throughout. Because the control limit is going to be the same for the entire data. Now to calculate the control charts, I'll start with the range chart. Now to plot the range chart, just select the range and the control limits, that is the blue cells on your screen. Go to the insert. Now in the insert, go to the chart section and in the chart select the line chart. Select a 2D line with marker and here we are with our range chart. So I'll also change the chart title to range chart. Similarly, we can calculate the X bar. So to calculate the X bar chart, what we have to do is, we have to select the green cells and the yellow cells. So I'll select this data of average and the control limits. So I've selected that and the routine is just like the range chart. I'll go to this insert tab, insert ribbon, and in the section of charts, I'll click on the line chart and I'll select a 2D line chart with a marker. And as you can see, here I am with the average chart. So I'll once again change the title to average chart. As you have seen the process of creating X bar R control chart on Excel, then let us quickly discuss regarding its interpretation. Always start with the range chart. If all the points are within the control limits, then go for the average chart. If in average chart also all the points are within the limits, then this means things are settled as of now, but one should also look for the validation of the control limits. Apart from the validation, if the situation is like, as you can see on the screen, if you are able to find out such as out of control situation, then in that case you need to inform the process supervisor. And simultaneously, you also need to discard the data and recalculate the control limits. If such a situation still persists, then repeat the process of discarding until 50% of the data is discarded. If such a thing happens, then this means that there is an assignable or a special cause which has occurred in the process and the team needs to activate the problem solving process to find and eliminate the assignable cause or the root cause. So, we can clearly see that a control chart helps us to statistically study the process variations, and moreover, it can also help us in predicting the future performance. That's it in this episode and the series. So with this video, we conclude the series covering the entire 7QC tools. We tried to cover and explain all the tools, that too in the crisp and an effective manner, so that it helps you and the budding professionals in an easy understanding of the 7QC tools. We hope that you have enjoyed the entire series, all the sessions, and if that is the condition, then do like each of our videos and subscribe our channel. We shall be coming up with more such episodes. Also, feel free to write your queries, suggestions and feedback in the comment section. You can also email us at the mentioned email address. Thank you everyone. Stay happy, stay healthy and stay safe.